We're going to write an equation of a radical function given the graph. Use the general equation f of x equals a times the cube root of x minus h plus k to write an equation for the graph below. So if you have an odd root graph, meaning it looks like an S, that middle point is your hk. That little turning point is your hk. If you have an even root graph, so you have a starting point and then it keeps going, your starting point, your vertex is hk. And then xy is any other random point on the graph. So that would be the 2, 9 here. So now we can go back to this equation. We have all of that information except this a. So we can plug everything in and we can solve for a. F of x is the same as y is 9. So 9 equals a we don't know times the cube root of x minus h. X is 2 minus h is 1. And then plus k on the outside, so plus 7. Now we can solve, we can subtract 7 to both sides. We get 2 equals a times the cube root of 2 minus 1. 2 minus 1 is 1. And we can keep going here. Cube root of 1 is 1. So now we have 2 equals a times 1. So then a equals 2. The question was asking to write an equation for the graph, but now that we have 2, we can come up with our equation. We want to leave x and y general, so we want to leave them as variables x and y, because x and y on this graph doesn't have to be 2, 9. Remember, it can be any point on the graph. But hk, that turning point for this specific graph, is always going to be this 1, 7. So we want to plug 1, 7 back into the equation, but leave x and y. So f of x, or y, equals a is always going to be 2 times the cube root of x can be anything, minus h plus k is 7. So again, once you plug in everything to solve for a, you can plug everything back into the equation except x and y. Looking at this example, it's a very similar question, but notice we're solving for b. So we're solving for a horizontal stretch or shrink, but it's going to be the same process where this is hk because it's our turning point, and this is xy. So f of x, or y, that's 2 equals cube root of b, we don't know, x minus h, 5 minus 2, and then plus k on the outside. Our solving is going to look a little bit different in this problem when we're solving for b. So we can subtract 1. 1 equals cube root of b times 5 minus 2. 5 minus 2 is 3. At this point, we can't continue to find the cube root of b times 3 because we have a variable inside that cube root. So what we can do is cube both sides. The cube root and cubed cancel. Now we have 1 cubed on the left equals b times 3 on the right. So that's 1 equals b times 3, divide by 3, so b equals 1/3. And then just like the last example, plug everything back in except x and y.